So good afternoon everyone. Today we will be discussing the Github Actions. So Github Actions is a continuous integration and continuous delivery platform that allows you to automate your what happens, build, test, and deployment pipeline. You can create workflows that build and test every pull request to repository. So basically, it's allowing the DevOps part, and then we can have the Linux, Windows, Mac OS virtual system virtual machines. Actually, understanding part, there is some event that is executed by runner, and one runner can execute only one job. So basically, you can configure Github Actions workflow to be triggered when an event occurs in your repository, such as pull request being opened or an issue being created. Pull request means somebody wants to make their changes to be merged into another branch which is protected, and an issue is something like box or feedbacks like enhancement, and each workflow that gets triggered by an event contains either one or more jobs which can run in sequential order and in parallel. So basically we can have the jobs that can be run in a sequential or parallel manner. Each job will run inside its own virtual machine, which is called the runner, or inside a container, or has one or more steps that either run a script that is defined or an actions are inside a container. So basically it can run in a virtual machine, which is called the runner, or inside a container, and it can have one or more steps that either run a script that you define or run an action. So basically there will be whatever it runs, that will be called a job, and that job either contains more than one steps, and that one step is defined either by the action or some script. For example, there happens to be execute one event that is being executed in runner 1, and maybe it is sequential in runner 2. For the runner 1 could be runner 1 is always a virtual machine. It's not a container. So basically runner 1 will always be the virtual machine, and anyways, so it's kind of a job that is being executed, and the job one is can either be a GitHub action, or it can some script or script action. So you can see one action, two script, one action, and then step 1 is running action, step 2 is running script, step 3 is running script. And for the workflows part, so basically what is the workflow? Okay, workflow is configurable automated process that will run one or more jobs. It's simple. So it's just that our workflow events trigger some workflow, and each workflow contains either one job or more than one jobs, one or more jobs. Workflows are defined in a ML file checked in your repository, and will run when triggered by an event in your repository. They can be triggered manually at a defined schedule. So basically, this is some kind of ML file, and that is a workflow that can be triggered by event manually or some scheduled manner. Workflows are defined in the GitHub/workflows directory in a repository. So we first create GitHub folder, then workflows folder, and then script.ml file, or let's say workflow.ml file. In a repository can have multiple workflows, each of which can perform different set of actions. Such as workflows are defined in a workflows directory in a repository. A repository can have multiple workflows, each of which can perform different sets of tasks, such as building and running pull requests. Workflows defined and can have multiple workflows, and each of that workflow can perform a different set of tasks. So it can perform different sets of tasks, like building and testing pull requests. It is building the pull request and testing that, or it is some deploying your application every time release is created. It is kind of integration and delivery. It is kind of integration. It is delivery. Pull request is being integrated. There is CI, and if the test passes, then it can be passed to deployment part. So CI/CD. This is useful, like adding a label. Why adding a label will be useful is there are some for now let it be. You can reference workflow within another workflow. For more information, you can reference workflow within another. So basically, it can be I would reference writing workflows events. Event is a specific activity in repository that triggers a workflow run. For example, an activity can origin from GitHub when someone creates a pull request, opens an issue, or pushes a commit to a repository. You can also trigger a workflow to run on schedule by posting to a REST API or manually. So event can be okay, so it is not an event, an event, and so jobs. Job is a event can be anything, so it can be manually. We can manually make events. Job is a set of steps, actions are on as a period. You can configure jobs dependency with other jobs. But jobs has no dependencies and run in parallel. So basically, if we need to make it sequential, we need to define it in that manner. When a job takes dependency on another job, it waits for the dependent job to complete before running. For example, you might configure multiple build jobs for different architectures without any job dependencies and packaging a job that depends on those builds. The job builds run in parallel, and once they complete successfully, the packaging job runs, basically making individual components and then making the whole component out of them. Action is a custom application for the GitHub Actions platform that performs a complex but frequently repeated task. Action is a custom application for the GitHub Actions platform that performs a complex but frequently repeated task. Use an action to help reduce the amount of competitive input that you read in your so action is some kind of repeated code. An action can pull a GitHub repository, pull your Git repository from GitHub, set up the correct toolchain for your environment, authentication to your cloud providers. So it's kind of authentication, building runners is a server, and each runner can run a single job at a time. GitHub provides Ubuntu Linux, Microsoft Windows, and Mac OS runners to run your workflows. Each workflow run executes in a fresh, newly provisioned virtual machine. GitHub also offers larger runners which are available in larger configurations. For more information, use larger configurations. Okay. Next step. So basically, it is very simple. Now let's see the continuous integration part. About continuous integration again. Continuous integration (CI) is a software practice that requires frequently committing code to a shared repository. There are more than one developer, and once the developer wishes fix some features, then we need to integrate that. And basically, after the integration, we need to run the integration test. Committing code more often detects errors sooner and reduces the committing code more often detects errors sooner and reduces the amount of code of a developer needs to debug. And finding the source and frequent code updates can also make it easier to merge changes from different members of our development team. This is great for developers who can spend more time writing code and less time debugging errors or resolving merge conflicts. When you commit code to a repository, you can continuously build and test the code to make sure the commit does not introduce errors. Your tests can handle code linters with style formatting. Linting is a kind of like one example is access, and in Python we cannot have exception class handle, like it needs to be some exception like predefined, but it's a kind of exception, so basically it needs to inherit from the exception, and then that's come some like PEP Python, some protocol encoding, no, part of the PEP full form, PEP Python enhancement, sorry. The building report requires solver. About continuous using GitHub Actions. CI using GitHub Actions offers workflows that can build the code in your repository. So basically, it needs to build the code and run your tests. As I mentioned before, can run a GitHub hosted virtual machine or machine that you host yourself. Okay. You can configure your CI workflow to run when a GitHub. This is, I think, some kind of what is called like we are ranking the website at the top listing on Google. So basically, search engine optimization (SEO). They have used this link in every article. They can read it, but it is useful. But anyways, I think this was one of the SEO approach that I had learned. You can configure your CI workflow to run when a GitHub event occurs. For example, when new code is pushed to your repository on a state of schedule or when an external event occurs using the repository dispatch by policy of Tron when GitHub event occurs. Okay, GitHub runs your CI test and provides results of each test in a pull requests. See whether the change in your branch introduces an error. When all CI tests in our pass, the changes you push are ready to be reviewed by a team member or a must. When a test fails, one of your changes may have caused the failure. When you run a CI in your repository, GitHub analyzes the code in your repository and recommends CI workflows based on the language and framework in your repository. For example, if you use Node.js, GitHub will suggest a workflow template that installs your Node.js packages and runs your tests. You can use the CI workflow template suggested by GitHub. Customize the suggested workflow template. Create one custom workflow file to run your CI test. In addition to helping you set up the CI workflow file, you can use GitHub Actions to create workflows across the full software development lifecycle. This is very useful because using the code repository like Git is a very competitive business. So this GitHub Actions is a very useful feature that should be introduced. I was just getting digress. In addition to helping you set up CI workflows for repository, you can use GitHub Actions to create workflows across the full software development lifecycle. In addition to helping you set up GitHub Actions create workflows for the lifecycle, for example, you can use deploy packages, release your project, workflow templates. There are some workflow templates. Let's understand the Python because I am very familiar with the Python. Browse the complete share templates of GitHub in the repository. Now let's understand the Python part. Also, let's open the development again. There should be some Django is a Python. There is I think Python Python package.conda. Let's just put and C++ also. C++. Okay. For the Django.ml, the name is Django Continuous Integrations. It is the name is a first keyword value. It is ML, right? What is the file? It was ml.file, and in the ML is defined in like key and colon space value on. So basically it's kind of just syntax. On push branches default branch, pull request default branch. Basically it is taking the argument dollar from the default branch. Very nice. Push branches on those branch, pull request on. So if push happens on a default branch, mainly main branch, or somebody wants to pull their somebody wants their changes to be merged to the main default branch, then the jobs are defined as below. Job number 1 is job is this. So basically jobs is this. A build job. The build job runs on at the runner is a Ubuntu latest. And what is the strategy? Maximum parallel for matrix Python version. I don't know max parallel, but Python version is need to bind steps. The jobs need some steps. Jobs maybe I think it's defined in more than one jobs. One of particular job build job has following steps. One is using the action /checkout /version flow. It uses checkout @version 4. I think some predefined thing over here. Name setup Python matrix.python version. So it is a name that is assigned. What.use actions with Python version name. This 1, 2, 3, 4 kind of jobs, and each job is kind of I think GitHub Actions. Yes. So it is pip install dash object requirements manage.py test. Okay, it is testing all the tests that it can find in the app. So basically Django will run the test. Now let's see for the Python app. It is again pushing on the push and pull request. Permissions contains read. This permission tab. Let me define. So Ubuntu latest steps are uses this with Python version, standing the dependency linked with the flaket. To link with the flaket, run the flaket dash count. Select is 9 if 5.3. So source statistics exit 03. So all there. So count flaket in this repository. Maximum characters, maximum line length. So the code cannot have line length with way much more code that has been not as, and because maximum complexity around PyTest. So basically it's a Python app.ml. Let's see C++. on the push or the pull request events. Run this workflow with the jobs defined. First, particular the build job, which runs in the runners Ubuntu latest, and the step defines are first the uses. It should use this one is the name, and for next second step, we should run dot slash configure. In the third step, type command run make. Run name is that's the action name. It can be anything, and the run is the command that it actually runs, and make check, and then make this check. Okay, this check. Okay, fine. So C++ also completed. Oh, there are lots of these. Okay, let it be. Now we are back to the continuous deployment, and the continuous deployment with GitHub Action. You can create custom deploy continuous deployment workflows directly in your GitHub repository with GitHub Actions. About continuous deployment. Continuous deployment is a practice of using automation to publish and deploy software updates. So it's simply like deploying the software. The code is built and tested before deployment. Continuous deployment is often coupled with continuous integration. So our continuous deployment using GitHub Actions. You can set up a GitHub Action workflow to deploy your software product. You can set up a GitHub Action workflow to deploy your software product. To verify that your product works as expected, your workflow can build the code in repository and run a test before applying. Okay. I think is an OpenID connect to access clouds. Okay, so GitHub Action allows access from cloud provider that supports OpenID Connect. You can just do offers templates and third party. So basically, I think continuous deployment is best understood with the example. Let us understand using an Azure app ready for deploying with GitHub Actions. Okay, there are some templates also in Azure. I have no experience in Azure. Maybe I think let's check some. This is a Linux machine. I think let's do the AWS Azure. IBM mentioned Terraform. Why is not there Azure Kubernetes service? AWS is okay, fine. AWS, but the Azure has too much detail. Azure Kubernetes. Let's just see Kubernetes service. I think that's what I need to understand. IBM, Google, Cloud Run, Tencent. Tested. It's very simple. On the push, there are environment variables: AWS region, ECR repository, ECR service, cluster, ECS task definitions. So basically, this is I think predefined container name. So content definition section for task definitions, which all are defined. Permissions, content set, job deploy, open the latest production checkout. AWS actions, content creation B1. So it uses this action. The action is called the configure. That action needs this key ID. What is the key ID? It's kind of username, access key kind of passport, region like your region is like country code or something east or west like that, and the name is name, and then second step of the job, run the Amazon actions, and that should run the Amazon ECR login. And the third build image is the ID environment run. So it's kind of a script, or let's say script as docker build -t. It build it, it pushes it, it echo GitHub output. Now the actions, so basically actions content name, okay, deployment instructions for actions. Amazon deploy task definition, service cluster, wait for service stability to. So it is running some configuration, building, testing, okay, pushing. Now let's see Kubernetes, how does it work. So basically it needs container, resource cluster, chart path and chart override path, and there are build image, permissions, access. You check out the repository this file is in. Checks out the repository this file is in. So basically, I just found what is the purpose of the actions. That step the checkout means checks out the repository this file is in. So basically, why is this necessary? Checks out the repository this file is in. I think it needs to be in that working directory. And then first is Azure login. I should Azure login, and this is a GitHub action. Client ID, tenant ID, subscription ID, very simple. And build and push image to Azure container registry. So we can push to any container registry, but the thing is that Azure ACR build, it is building and then pushing, very simple. And the deploy is another. This one is first thing building the image, second one is deploying the image. First was build and deploy it to some container registry. A container registry can be anything. In this case it is Azure. And then a deployment means we need to actions contents. So basically let's say what is the build image. So dependency deployment is dependent on another build image of. The steps are very simple. Using the checking out. Second is logging in using the client ID, tenant ID, subscription ID credentials, and then cube login for so basically now the Kubernetes part is over here. First thing is that cube login. First thing is logging into the Kubernetes master plane, and then AKS set context, resource name, cluster name, admin, use kube login. So using the retrieve Azure Kubernetes service cluster name kube config file, runs Helm to create I think this is specific to Azure platform. So it's just a render engine. Helm chart override files, overrides replicas to Helm version latest. So basically it is overriding the manifest files. Maybe it's like manifest means how to like configuration file. And finally deploying the part is Azure creates deploy, action to track is deploy, and then manifest is our manifest bundle as maybe defined over here. It's just outputs, and then big outputs is ID is big, and that big is taken over here, and outputs of that, and manifest bundle of that outputs. So images are registry azure.io/content name or github.ss. Okay, in this way this deployment Kubernetes service, maybe I should understand building the image is same for all, deploying the image also same for all. Logging we should log into the Azure credentials. Then we should use the kube login to after we log into the main machine, we again log in the Kubernetes part, and after logging into the Kubernetes part, we need to read the configuration file. And what's the configuration file? And after we log into the configuration, after we get the configuration file, we deploy the applications. And for the deployment part, is just we just need to define what is the image that is the new. The latest image is just defined in the build image process over here. So basically, first we build the image and we push it in the container registry, and in the second steps we log into the Azure main machine, and then I use the login kube login to in the Kubernetes cluster login or the control over the master plane, and to retrieve the manifest file. It's kind of deployment.ml file for the Kubernetes part. If you do not the service, and then after we get the complete control over the Kubernetes, its cluster, its configuration file, we just need to run the fetching the new image from the GitHub, from the container registry, and take that image and make the ports running in that with that new image containers. So basically it's very simple, and there are lots of examples. So basically now I think I need to I found that it is being asked in every interview question, so I just had to go into depth. Actually I had been using this for about 1 year. I used this for 1 year, and now we are not using it. We are just using manual operation, like there is no more frequency ICD in our cases. I written a script to automate all this without the help of Github Actions. So okay, thank you everyone.